Welcome to this quick little video, a little extension from lesson 5. This one is going to be specifically about kites and trapeziums. And we're really going to go ahead and get trapeziums out of the way. So trapezium is really just another word for trapezoid. Sometimes it is used to refer to trapezoids that specifically have no congruent sides. However, lots of people just use the words trapezoids and trapeziums interchangeably. So we're going to focus this lesson on the kite. So a kite is a quadrilateral with two distinct pairs of consecutive congruent sides. So let's break this down a little bit. Distinct pairs means that it is just going to be a pair of congruent sides. So these top of the kite are congruent, and then these two longer bottom are congruent. When I'm emphasizing distinct, because they're going to be different. So it's not a square. What makes it different than a square is that these two are different than these two pairs of consecutive congruent sides. Naming the parts, there are vertex angles, there are non-vertex angles, and then there are diagonals. So we'll start with the diagonals since we have seen those before. In this kite, there's diagonal AC, and then there is diagonal BD. So let's take a closer look at vertex angles. So we do have 4 angles in a quadrilateral of the kite. The vertex angles are what you're going to call the top and bottom of the kite. So they're the ones that are connecting the congruent side. So it's the ones that are between the congruent angles. So in this case, the vertex angles are angle B and angle D. So the non-vertex angles would be angle A and angle C. They are the angles that connect the non-congruent sides. So the vertex angles are the top and bottom. They connect the congruent sides. The non-vertex angles are the angles that connect the non-congruent sides. It is important to recognize which ones are which, non-vertex versus vertex, because they have their own properties. The non-vertex angles of a kite are congruent. So coming down here, the non-vertex angles are the ones that are connecting the non-congruent sides. Maybe that's a way to remember it. Non-vertex connects the non-congruent sides. So these angles are congruent, and the vertex angles of a kite are bisected. So the top gets cut in half and the bottom gets cut in half. But again, notice that I use 2 arches here and 3 here because these angles, the vertex angles, are not congruent to each other. So this top is not going to be the same angle as the bottom, but the diagonal cuts them in half. So whatever this angle is here, it's the same over here, here, and here. But the top does not match the bottom. It's the sides that match, but that diagonal does not cut does not cut the angle in half. So this is congruent, but we can't break it down based on the diagonal like we can with the vertex angles. One more thing to note about the diagonals, similar to our rectangles and, our rhombus, not our rectangles, the diagonals connecting the vertex angles are perpendicular. So we do have 90 degrees inside here. Let me make that a little nicer. We have 90 degrees inside there. And then actually even more specific than that, it says the diagonal connecting the vertex angle, so this longer diagonal, is a perpendicular bisector for the other one. So not only is it perpendicular, it's a bisector. So the short pieces are going to be congruent. Let me make 3 tick marks there. Since I'm using 3 tick marks because the 1 and the 2 are already taken, so that's why I'm using 3. So this short, the non-vertex to non-vertex diagonal, that gets cut in half by the other diagonal. So perpendicular, bisector, and so these are going to be the same as each other. But this long diagonal from vertex to vertex does not get cut in half. So let's see if we can use that information to help us find missing measurements. The first one I'm going to draw attention to are the congruent ones. So 118 is congruent to the x. The non-vertex angles are congruent to each other. So the ones that are connecting the non-congruent sides, the non-vertex angles are congruent. So x is 118 degrees without any work. In order to find y, we have to remember that y and the 45, these vertex angles are not congruent. So we can't just make that 45. Instead, what I'm going to do is I'm going to add the 118s and the 45 together to get 281. And then we have to remember that there's 360 degrees inside of the kite because it is a quadrilateral. So I can take the 360, subtract 281, and I get y as 79 degrees. This next problem seems to be dealing more with angles inside. I don't have any variables trying to figure out side length or length of diagonals. This A is measuring this angle space here, and this B is measuring this angle space here. So because we're dealing with angles, I did go ahead and copy this property. The diagonal connecting the vertex angles of a kite is perpendicular bisector of the other diagonal. And I'm not worried about the bisector part, but I am worried about that perpendicular part, because what that is going to do is going to help me find, since I have right triangles, that's going to help me find my missing angles in here. Now, one of the other properties is that these two angles are congruent. So if it's 65 on the right-hand side, it's also 65 on the left. And so all I have to do is do 90 minus 65 because since it's a right triangle, there's only 90 degrees left for the 65 and the A to share. So if I take 90 and subtract 65, that's what A is going to equal. So A is 25 degrees. And essentially, I can do that same thing down here to find B. Because the properties of the non-vertex angles, so going from the left side to the right side, is that they are congruent. So let me use switch colors here. Two arches, so these are congruent. And though the diagonal does not create congruent angles here, like A does not equal 68, we just calculated A to be 25, but since this is 68 down here, it is also 68 over here, and so it's also 25 inside there. Like, so all of that is the same from the left side to the right side. And because it's a perpendicular bisector, it's 90 degrees here. So in this right triangle where B is, I have 90 degrees and I have 68, and I just need to find B. So I'm going to take 90 and subtract 68 to get 22, and that's what B is. And so if I wanted to label more, if this down here is 22 degrees, then this is also 22 degrees. So remembering that this angle, which is 44, is not the same measurement as the top, but that the diagonal just cuts it in half. These non-vertex angles are congruent to each other, but the diagonal does not cut it in half. So it's kind of an opposite relationship between the vertex angles and the non-vertex angles. But that's how we can use it to find our missing angle values.